Okay, problem 3 is this boy on a trampoline taking a little break from the Star Wars problems. Don't worry, we'll get back to it. And so the boy starts, I think, with the trampoline depressed by d equals 0.75 meters. And we want to know what's the height he gets to above the rest position of the trampoline. So I'm going to call this state 1 here, where he's got the trampoline depressed by 0.75 meters. And this is like the bottom of his bounce, right? So he stopped moving down there. And then up here, he is at the very top of his flight. So he has also stopped moving here at stage 2. Hi! That's my wife getting home. So let's see. Let's do... And 3 here is not a state. That's just problem 3. So sorry about that. So anyway, for state 1, we have the trampoline behaves like a Hooke's law spring, right? So he's depressed it. We're going to say its rest height is 0. And so he's got some potential energy, some spring potential energy, which is 1/2 k, whatever k for the trampoline is, I forget what it was, but 1/2 k times the amount the spring has been deflected from its rest position, which is d squared. Okay, so this is the spring potential energy of the trampoline. The gravitational potential energy, well, first we have to decide where we're going to set gravitational potential energy equal to 0. So I'm going to arbitrarily, it's an arbitrary choice, right? I'm going to say UG equals, actually, you know what I'm going to do? I'm not going to do that. I'm going to say UG is 0 when he is at the bottom of his trampoline bounce, just to make the math easier, okay? So that this position D down from rest, from trampoline relaxed, he is at potential energy 0. And also his kinetic energy there is 0 because this is the very bottom of his bounce. So he's reached the bottom and he's just about to start bouncing back up. Okay? Now at state 2, the potential energy from the spring is 0. We're just going to say the trampoline, once he leaves the trampoline, it stays there flat. So the potential energy for the spring at stage 2 is 0. Potential energy from gravity at state 2, well, we said it was 0 down here, right? So his potential energy later on is going to be mg times whatever height he's gotten above that. In that case, he came up, or in this case, he came up this distance d and then went up a further h. So this is going to be mg times d plus h. And this h here is what we're trying to find, right? This is how high he goes above the rest position of the trampoline. Okay, so let me just draw a line in there to make it clear that we're doing 2 different states. And then also at the very top of his bounce, he is once again, very briefly motionless, instantaneously motionless. Okay, so his kinetic energy is 0. Okay, so again, this is a very simple conservation of mechanical energy. So Emac here, we're going to assume no non-conservative forces. I think the problem says that, but if it doesn't, then that was really what was intended. So this is our Emac there, this is our Emac here, and mg d plus h. And then so we just set these two equal. We're going to say Emac at 1 equals Emac at 2, which means 1/2 k d squared equals mg d plus h. And so I think we were given, I guess we want to solve for h, so I suppose we can do that. So we can do h plus d equals k d squared over 2mg, so it's just dividing through by the mg, solving for d plus h, and then we can get h equals k d squared over 2mg minus d. Okay, so I forgot what, let's see, k was 2,500, and the mass was 30 kilograms. So if we plug this in, let's see, h equals 2,500, 0.75 squared over 2 times m times g. So that's m was 30, and I'm going to use 10 for g again. So this is going to be a total of 600 under here minus 0.75. And I'm at the edge of the tablet, so that's why I'm screwing up there. But 2,500 times 0.75, I don't know. I think people were telling me I mean, if you really want to figure this out, you can. People were telling me they were getting like this term was coming out to be like 2.39, which I guess I can kind of see. So let's just, I'm going to say, I think the height was about, it was 2.39 minus this 0.75. So 2.39, 2.34. So I think the height he goes above the rest position of the trampoline is going to be about 1.64 meters. Okay. Can't swear to that, but I'm pretty sure that's what it is.